Hello and welcome back to another video. In this problem, we're given the equation for the speed of a sound wave in air, where A represents the speed of the wave and T represents the air temperature. We're asked, at which of the following air temperatures will the speed be closest to 1000? So we're looking for these following air temperatures, and if the air temperature is represented by T, then all we have to do is plug in -46, -48, and so on in for T, and we'll get our values for A. We can see which of those is closest to 1000. So we have A is equal to 1052 plus 1.08, and then plugging in for T, we have -46. For B, we have the same thing, except plugging in -48. C, again, similar thing, plugging in -49. And D, last but not least, plugging in -50. If you calculate all these using your calculator, to save time, we get 2.32, or sorry, we get, not 2.32, not there yet. We get 1002.32, we get 1000.16, we get 999.08, and we get 998. So these are your four speeds at the following air temperatures. And now we're saying which of these is closest to 1000. So you take these values and you subtract 1000, and you take the absolute value of that. That is the distance between them. So if it's greater than, then okay, you could have just taken the difference, 1002 minus 1000. But if it's less than, we're gonna get the positive difference. So this comes out to the absolute value of 2.32, which is 2.32. We get the absolute value of 0.16, which is 0.16. Here we get the absolute value of -0.92, which is positive 0.92. And here we get -2. Absolute value of that is +2. So which of these is closest? Well, it's the one with the shortest distance between them. So what is the smallest number out of all of these? 0.16. Which means that B, -48 degrees Fahrenheit, is closest.